Dear students and friends, in our last video, we discussed about the basic concept of differentiation and we discussed application of that differentiation, especially in the case of that kinematics. And most of that students feel difficulty regarding the reverse process of that differentiation, which is known as integration. So in most number of occasions they may use integration in the case of differentiation and differentiation in the case of that integration. In this video just I want to give clarity regarding that integration, when we have to use that integration and when we have to use that differentiation, how these two are opposite or reverse of each other. I am able to explain with one or two examples. Okay, so in the case of that integration, that means in the case of that, if I want to consider one function, if y that is equal to f of x, some function of x, if y equal to, so take this equation, differentiate this equation y, differentiate this y with respect to x. For example, take this as equation number 1. Differentiate equation 1 with respect to x. Then what will you get? Dy by dx. Dy by dx. Derivative of y with respect to x. Then compulsory you will have one more function that is also in terms of x, which is equal to, here I can say some f of x. So this function is different, hence I used that difference. This is capital F of x, whereas this can be taken as a function of x, some other function, of course that is also x. Now dy, if I want to take, this can be considered as f of x dx. Therefore you want to consider that integration process. That means you want to see the total change in the value of y as x changes from x1 to x2. That means you want to see the total change in the value of y as x value changes from x1 to x2. So that can be considered as integral dy. This is known as integral operator. That means integral, while pronouncing you have to use integral dy, that is equal to integral f of x dx. As I said, the total change in y as x changes from x1 to x2, here you have to consider that value, that is y1 to y2. That means total change in y means, here you can write therefore y2 minus y1, that is equal to integral y1 to y2 dy. Then you can consider this value equal to y equal to f of x. Here you consider 2. That means f of x2 minus f of x1. Hence you are integrating that equation with certain limits and you are able to get that value. Or in simple I can say that differentiation and integration, these two are quite reverse phenomenon. So I want to go for that one. Y equal to f of x, you are considering that as equation number 1. Differentiating equation 1 with respect to x, dy by dx equal to f of x, dy equal to f of x dx. That means this operator is integral. Therefore y1 to y2 dy, that is equal to integral x1 to x2 f of x dx. That means, as I said earlier, total change in value of y as x changes from x1 to x2. So that is the meaning of that. Hence I can say this is nothing but y2 minus y1 equal to integral y1 to y2 dy. This is lower limit, this is upper limit, that is equal to f of x2 minus f of x1. Hence this is to be followed. Let me explain with one or two examples. Just like in the case of the differentiation, here also you are having some formulae, some basic formulae. If you are able to understand that basic formulae, then you may go for that application of this integration in the case of our physics related problems. Now I want to explain one or two most important formulae that we use number of times. That is, if I want to take integral x power n dx, integral x power n dx, this formula that can be considered as x power n plus 1 by n plus 1, x power n plus 1 by n plus 1. If there is no limit here, here there is no x1, there is no x2, here there is no limit, hence this can be considered as indefinite integral. In the case of that indefinite integral, you should have to write one constant c, where c is known as some integration constant. Remember, this constant can be used when there are no limits. Hence I can say this is nothing but indefinite integral. Indefinite integral. For example, if you want to take the same equation, the integral x power n dx, here values are x1 to x2. Formula that is same, x power n plus 1 by n plus 1, and you should have to consider these limits. Lower limit is x1, upper limit is nothing but x2. Here there is no need to write that constant c. Here n plus 1, that is nothing but general value, that means independent of that x value. Hence I can write 1 by n plus 1. In the place of x, first write upper limit x2 power n plus 1 minus, in the place of this x write lower limit x1 to the power n plus 1. Hence this is known as definite integral. This integration, that is nothing but definite integration. You know that limits, starting limit, lower limit, and ending limit, upper limit. Hence I can say this is nothing but definite integral, or I can say that is process is nothing but definite integration. So in the case of that indefinite, you have to use this constant. Whenever you are having limits, in the case of that, there is no need to write that constant. So this is the basic formula in the case of that integration. As in the case of that differentiation, what we consider d by dx of x power n, that is equal to n into x power n minus 1. Here this is integral x power n dx equal to x power n plus 1 by n plus 1 plus c. Now if I want to go for the next part, that is nothing but integral. If you want to take some constant, integral of that some constant value, you can write that is non-zero. In the case of that differentiation, we consider differentiation of that isolated constant, that is equal to 0. Here that is not equal to 0. For example, if I want to take integral some constant dx, integral some constant k into dx. As you know, this k can be taken as outside integral 1 dx. 1 can be written as x power 0 dx. Once again, you can take k into x power 0 dx means x power n plus 1 by n plus 1. Once again, here there are no limits, hence you can take constant. Do not get confused with these two constants. This constant is for integration constant. So this is a constant in the problem. That may be 2 or 3 or 4, whatever it may be, some number, or in the case of that mathematical constants like that. This is the constant and this is nothing but integration constant. As I said, this integration process is a reverse process of that differentiation. I can tell you one simple thing, that is nothing but d by dx of x square. Just I want to take d by dx of x square. What does it mean? Which is in the form of x power n. You can write 2 into x power 2 minus 1. Hence you are able to get 2x. As I said, in the case of that, this is nothing but 2x. After that you can write 2x dx. If you want to take integral 2x dx, if you are integrating, once again you will get that x square. How? Take that 2 that as constant outside. 2 into integral x means x power 1, that is nothing but dx. Here I don't want to mention any limit. After that use that equation x power n dx. Then you can take 2 into x power 1 plus 1 by 1 plus 1 plus c. Therefore, this is nothing but 2 into, this is x square by 2. 2 and 2 gets cancelled. Hence, you are able to get that basic equation once again. Here you are taking x square. You are differentiating with respect to x. Then you got 2x. If 2x dx you are integrating, once again I can say you are able to get x square. Therefore, I can say the process of differentiation and integration, these are reverse, quite opposite. Reverse phenomenon. So, in the case of that application, just I want to discuss about more physics application. You are having number of equation that you may come across in your mathematics course. If I say x is displacement, sometimes you can also use s also. X is displacement, v I can say velocity, a acceleration. These models are important in the case of your mains level examination or NEET level, or in the case of advanced level also you can have these kind of models. Just I want to give that basic of that. So x that is nothing but displacement, v that is nothing but velocity, a that is nothing but acceleration. All these parameters we are considering with respect to time. For example, I want to take that first one, that is x. X is a function of time. The process that is same. If you are differentiating with respect to time, dx by dt, then you are able to get velocity. Differentiating that, you are able to get velocity. So in the case of that integration, dx that is equal to v dt, integration on both sides, integral dx that is equal to integral v dt. For example, if this is x1 to x2, here I can say t1 to t2. That means x is a function of time, then you are considering that differentiation with respect to time, that displacement, you are able to get velocity. If you have velocity, you are integrating, then you are able to get that displacement. Therefore, you should have to see that quite reverse phenomenon of those two. Similarly, if I want to take velocity v, that is a function of time, if you are differentiating with respect to time dv by dt, then you will get acceleration. Even in the case of that differentiation we discussed, that is nothing but instantaneous acceleration. For example, if you want to take dv, that is equal to adt, integration on both sides, then integral dv, that is equal to integral adt. Here that limits you can take v1 to v2, here t1 to t2, then you are able to get velocity. Therefore, if you consider these equations, you have to consider whether we have to follow differentiation or integration. So, I will give one simple example regarding these two, which is known as loop formulae or loop method. Without facing any confusion, simply you may go through that values. That is x, as I said, displacement, v, that is nothing but velocity, a, that is nothing but acceleration. Displacement, velocity, acceleration. You are differentiating that x with respect to time, you are able to get velocity. If velocity, that is differentiated with respect to time, then you are able to get acceleration. If you want to differentiate acceleration with respect to time, you will get jerk. Here I don't want to discuss about that jerk, just I want to restrict my lesson up to that acceleration. Now I am coming back. You are integrating that acceleration. This is nothing but integration. You are able to get velocity. If you want to integrate that velocity, I can say you are able to get displacement. Therefore, this method is known as loop method. Especially that intermediate students and competitive examination students or NEET students, without any doubt, you can see if velocity is given, if you want to get acceleration, go for differentiation. If acceleration that is given, if you need velocity, then go for integration. For example, acceleration that is given, if you need displacement, go for double time integration. If displacement is given, you need acceleration, double time differentiation. So basing on that, you should have to go through that values. So in physics, you can see that velocity based, acceleration based, like this. Not only these two, in the case of that dynamics also, especially if you want to consider dw, that is equal to f dx, after integration you are able to get work done equal to integral dw, that is equal to integral f dx. Therefore, for work done you can take integral f dx. Similarly, according to Newton's second law of motion, F, that is equal to dp by dt. The rate of change of momentum is directly proportional to external force acting on it. F directly proportional to dp by dt, F equals to dp by dt. That constant of proportionality 1. Then dp, that is equal to f dt. Integration on both sides. Integral dp equal to integral f dt. Once again, here p1 to p2 momentum, here t1 to t2 time. Hence you are able to get that change in momentum, that is equal to integral f dt. See, this example problem. The acceleration of a particle is increasing linearly with the time t. That means acceleration increasing linearly with t. So the important word that is acceleration and linearly with t as bt. Of course, small b is a constant. The particle starts from origin with an initial velocity v0. Initial velocity is v0. Now you have to find distance traveled. So this is to be determined by the particle in time t will be. So acceleration is given, some velocity information is given. Now you should have to go for that distance traveled, or I can say displacement in the case of that straight line. So by using that loop method, acceleration is given, you need a distance or displacement, means you have to go for integration phenomenon. In the case of first one, if acceleration, that value can be considered, this equation can be considered, we will integrate, then you will get velocity. After that you may go with second time integration and you are able to get that distance. Okay, here I want to take that equation, since that problem part data that is clear for us. Hence I can take acceleration that is equal to here bt, where b is a constant. Then acceleration can be written as dv by dt, that is equal to bt. Therefore dv that is equal to bt dt. This is nothing but dt, bt dt. Integration on both sides. Integral dv that is equal to integral bt dt. So in the case initially, when time that is equal to 0, its initial velocity is given as v0. Writing limits is most important for us. Here starting, I can say when t that is equal to 0, it is having some initial velocity v0. After certain time t, its velocity can be considered as v. As you know, integral dv means 1 into dv. Then you can write v power 0, anything power 0 that is equal to 1. Hence directly by using that x power n equation, here this value is nothing but v. After integration, you should have to apply that limits. This is v0 and this is v. Here b is a constant, take that as outside. Here this is t means t power 1 dt. Limits are nothing but 0 to t. That means t power 1 plus 1, you will get t square by 2. Limits are nothing but 0 to t. So in the place of that t, you can apply t. Minus in the place of t, if you write 0, that part is 0. Hence you are able to get directly 1 by 2 bt square. That means here apply that maximum value v minus v0, that is equal to, I can write half bt square. Therefore v that is equal to v0 plus half bt square. So you are able to get first velocity. In the case of that first time integration, you are able to get velocity v equal to v0 plus half bt square. Now if you want to take that v, once again v is nothing but ds by dt, that is equal to, take this value v0 plus half bt square. Now ds can be written as v0 plus half bt square. This is nothing but dt. Once again you can go for that integration process. Directly I can write integral ds that is equal to Here you can separate these two, integral v naught dt plus integral half bt square dt. Even in the case of that differentiation we discussed u plus or minus v plus or minus w, you can differentiate separately. Here also this is in the form of two quantities with combination, you can integrate separately. Whereas in the case of that, here you can take starting, let it be some 0 and let it be t, here also 0 t. In the case of that, here if you want to take 0 to s, initially that can be considered as 0 and this is nothing but some s. So integral ds means directly you can write yes. After application of that limits, you are able to get yes. Here v naught, that is a constant, take that as outside. Then integral dt means t. First write t minus 0t. Hence you will get v naught t plus here half b is a, I can say, constant. Integral t square means t power 2 plus 1 by 2 plus 1. Then you will get t cube by 3. Even if you want to apply these limits t and 0 in the place of t, first write t, you will get same. Minus 0 means 0 cube by 3 means that is 0. Therefore your final answer S that is equals to v naught t plus 1 by 6 bt cube. Yes, that is equal to v naught t plus 1 by 6 bt cube. I think you might have get that answer. So this is advanced level question, previous advanced level question. When acceleration that is given, you are able to obtain the displacement s equal to v naught t plus 1 by 6 bt cube. Okay.